toolbox, results, comparison, conclusion, and the references. A solar PV system has become one of the important sources for the generation of power in the renewable energy after the wind, because 3.8 into 10 raised to power 24 joules of energy falls on the Earth's surface that can be utilized for the generation of electricity if the harvested energy is tracked at a higher efficiency. The solar cell have the non-linear characteristic, that means the IV and the PV characteristic are dependent upon the irradiation in the temperature. Whenever the irradiation in temperature is going to vary, then the maximum power, the tracking of the system changes. So to track the maximum power and to extract with a higher efficiency, we use the MPPT technique. In this paper, the soft computing technique has been used because it has some advantages like high tracking speed, a self-learning approach, and the dependency on the system model is very less. The performance parameter that has been considered is that the output should have the few ripples, high settling time, and higher efficiency. This is the overview of the module that we have considered. In this, we have considered a solar cell that is having the wattage rating of 0.66 volt and 0.1 ampere. Total 24 cells were utilized, and by the help of the pyrometer and the temperature gun, we have measured the value of irradiation in the temperature that is falling at different time. So, this is the IV and PV characteristic plotted for 24 cell at the 886 watt and 25 degree centigrade. To analyze the effect of temperature and irradiation falling on this PV panel, we have taken the two cases. In this first case, the temperature is kept constant and the irradiation has been varied for 886 to 729. In second case, the irradiation has been kept constant and the temperature has been varied from 20 to 50 degree. This is the IV and the PV curve that has been obtained by the help of the MATLAB, and we can see that when the effect of irradiation on the module is changing the current value at every point, but the voltage somewhat is near to the 36 volt. This, as the different radiation has been considered, that 886, 739 and 500 and 300. And the effect of the temperature, we can see that it is going to vary the value of my voltage. The current remains somewhat near to the ISC value, but the VOC value is going to change at every point. So that's why the tracking of the maximum tracking or the maximum power exacted at every irradiation and temperature is going to shift. From these two graphs, we can analyze that the irradiation affects the current's value and the temperature is going to affect the voltage, that is the VSC and the ISC value. This is a basic circuit diagram of the paper that we have considered. In this, with the PV array or the module has been considered, which is having the module circuit is the VOC value is taken this, and the ISC is approximately 0.625, and L and C inductor and the capacitor value has been calculated for the boost converter. Then we have for the PI controller, we have the proportional gain and the integral gain value of 0.1 and 0.005 with the switching frequency of 20 kilohertz. This is the ANN input data. The ANN we have used, the irradiation, the temperature is the input, and output is in the terms of the power. This is the maximum power point tracking. Artificial neural network is an interconnection of the neuron structure that transmit from message from one neuron to another. These interconnections have the numerical values that is based on the experience. This is the MPPT. This point is known as the maximum power tracking, that is the VOC and the ISC of the panel is decided, and for different radiation, the different temperature, the VMP and IMP is going to vary. For that case, we have used the ANN. These ANN have the three important parameters. That is, first we have to define the input and output variables. That means we should be sure which parameter have to be taken the input and in what terms we need the power. Then the network architecture, selection of the data and the hidden layer. If the extracted data or the experimental data that we are having is somewhat having the accurate, then the hidden layer will be reduced, and if the error is more than the hidden layer have to be increased in that ratio. Then we have the network training and testing. Some percentage of the data has been taken for the testings, and some should be taken for training, and some have to be taken in the terms of validation. To check the performance of ANN, we calculate the mean square error that is based on this formula, that is F is equal to 1 upon N, and it represents the EPOS, or we can see the iteration value, with the TI minus of TA, where A represents the present output that is that the PV module is producing, and TI is the targeted value that we need. This is the DC to DC converter in the PI controller. This is the boost converter that is used to step up the voltage, the low value to the high value. In this paper, 36 volt was the PV module that has to be boosted to the 60 volt. So for that, the boost converter operates in two modes, that's the mode of the conduction and the mode of blockage. Inductor and capacitor are the storing element. In the conduction mode, the inductor is going to store the energy. In the blockage mode, the inductor will act as a source to the capacitor and it will provide the higher voltage to the system. This is the input and output relation with the terms of the duty cycle has been given, where V0 represent the output and Vt represent the input. The input of the system will vary according to the irradiation and the temperature, but the V output is fixed, that is the 60 volt, and the duty ratio is going to be managed according to that. The Ki and the Kp are the proportional constant and integral constant. That is, integral value is used to increase the settling time, and the Kp value is used to reduce the steady state error. This is the basic formula of the boost converter. The calculation of the inductor capacitor, the switching frequency for the system is 20, and the V output, that means the output voltage ripple should be less than 1%. This is the condition we have considered. This is the designing of ANN MATLAB. In the MATLAB we have used the ANN tool. This is the ANN tool in which the radiation and temperature are taken as the input. That value lie from 61 to 86 watt per meter square, and the temperature is going to vary from 5 to 36 watt. And the output of the ANN is in the terms of the power, and this W represents the weight and 10 represents the hidden layer. The VOC and the ISC value has been taken from the experimental data, that is having 36.978 and ISC is 0.58. As we have said that when we are going to use the ANN, we have the three variables that have to be defined. That is, first the input and output. In this case is the module temperature and irradiation. Output is in the terms of the power. Then we have the hidden layer. Some percentage of that has been taken for training, that is 55% has been taken for training, and validation 25%, that is having 49 values, and then we have taken for the testing data. This is the result. The data division is known as the random, and the performance has been calculated in terms of mean square error. This is the EPOS, means the number of iteration for what value we are calculating the error. This is the basic design using the MATLAB and simulation. This was a 24 PV cell module that has been taken here, and this is the irradiation. The temperature value for the simulation has been taken from 886 to 147 with the temperature value of 22 18 degrees centigrade. This was the ANN controller. This is the boost converter. This is the PID controller has been integrated in the system. These were the output of the ANN. The simulation time has been kept 1 second, that is valid for 0.1, and the mean square error has been calculated with the regression value of 99.6%. That means the data that we have taken have the error value of 10 raised to power minus 1 with the training value of 99.681. The regression value gives the accuracy of the model. Then these were the results we have considered. For 0 to 0.2 seconds we have calculated the irradiation at 886. The module was able to produce a voltage of 22, and the boost converter has boosted a value of 61.65 with the efficiency of 96%. Similarly, from 0.2 to 0.3 the irradiation was kept 778 and the temperature was 27, and at that the efficiency has been calculated 99%. At 0.9 and 1 time period, the irradiation value was very less, that is 147, and the temperature was 18 degree, and the system was able to track 90% of efficiency has been obtained in this. The curve should, the output should have the less ripples. This was the condition that we have considered. This is the output of the ANN. The blue curve represents the temperature, black represent the blue curve represent the irradiation, black represent the temperature, and this is the ANN output in terms of the power. This was the output of the boost converter in terms of voltage, current, and the power. This is the final result that we have obtained. As we can see that the module voltage was unable to the module with the change in the irradiation, the temperature, the module was not able to track it at a higher value. By using the ANN controller, by using the ANN and the PI controller with the boost converter, the output was able to keep the voltage at till 0.6. It was able to track to 60 volt, and the output ripples in this is very less, and it have a smooth curve. that is the voltage, current and the power from the boost converter. This is a brief comparison has been done. In this we have taken the maximum, we have considered the STC value with the voltage of 23 that was boosted with the efficiency of 99% at STC, that means 1000 watt and 25 degree, the efficiency was 99%, and at 778 it was 27 degree with the efficiency of 99.75. Now we have considered the effect. The irradiation has been varied and the temperature has been set to 25. The irradiation value has been taken maximum and the minimum to check that the efficiency. For the maximum value of irradiation, the efficiency was 99%. For the minimum value of irradiation, the efficiency was 91%. If we talk about the ripples, then the ripples in the module was 0.45, but whereas in the boost converter voltage value was 0.09, which was less than 1%. Similarly, in this case, with the temperature has been varied and irradiation has been kept constant. That means for the higher value of the temperature and the lower value of the temperature, the efficiency at 36 degree it was 98%, and at the minimum temperature it was 85%. But at the lower ripples, the module was producing the ripples of 3.786 volt, whereas the boost converter was having a very small ripple that was 0.04833. So for the conclusion of the paper is that in this paper we have used the ANN technique, that was 195 experimental data was trained according to the regression curve was 99.6% with the RMS value for 1000 EPOs, and ANN output of the panel has been used to calculate the error, and the PI controller has reduced the steady state, and the PWM generator has generated the gate pulse to the converter section. And the output, in the output we have seen that the ripples are very less and the smooth waveform has been obtained at every environmental condition. The PV system was this PV system was designed for 60 volt system that was boosted to 60 volt for the 36 volt system. L, that was inductor capacitance and load resistance of frequency has been calculated for the 60 volt system. That means if the boost converter value have to be changed, then all the value of inductor capacitance and resistance have to be varied in that ratio. At 776 watt, the 31.80 volt was the output of the panel that was boosted to 61.95 with the very low ripples of 0.791. The desired output of 60 volt was obtained at 778 and 27 degree with the efficiency of 99.7%. At the fixed radiation, the maximum and the minimum efficiency was 98 to 85%, and for the fixed temperature, the efficiency was 91 to 91%. So we can say that the ANN give the better response in all the climatic conditions with the higher efficiency, and so the ANN can be used with the MPPT technique. These are the references that has been considered in this paper. Thank you.